Section 25 is adding and subtracting fractions with unlike denominators. For example, 3 over 4 plus 10 over 8. The denominators are different. One denominator is 4, the other is 8. But you can divide in the second fraction the top and bottom by 2, and you'll get 5 over 4. So the record, if you were able to divide by 4, if you had 3 over 4 plus 12 over 8, I wouldn't divide the top and the bottom by 4, because then I would get 3 over 2, and my denominators are different. What I would do instead is saying, you know what? If I divide by 2, then the denominators will both be 4. And then you would get 3 plus 6, which is 9 over 4. Okay, in our problem, we have 3 over 4 plus 5 over 4. In addition, denominators are the same. Keep them the same. Add the tops. 3 plus 5 happens to be 8. And 8 divided by 4 we should know. And if you really don't know what 8 divided by 4 is, don't tell anyone. You can still do it easily. 4 times what equals 8? 2. 4 times the number in the box should equal the numerator, which is 8. 4 times 2 is 8. So the answer is 2. 3 over 4 plus 10 over 8, that equals 2. If you have 3 over 6, and you want to add 2 over 9, well, I would reduce it. I'd rather not find the LCD of 6 and 9 when 3 over 6 is really a half. I'd rather find the LCD of 2 and 9. That's going to be 18. On the 9 table, you have 9, 18. I'll stop there, because on the 2 table, it has each and every even number, and no odd numbers. 9 is odd, 18 is even. Eventually, on the 2 times table, you'll hit 18. Every even number is on the 2 table. So I want to write 1 over 2 with an 18 on the bottom. I want to write 2 over 9 alternately with an 18 on the bottom. It is, I want to change the way the fractions look. I don't want them to have 2 in the bottom anymore. I don't want it to have 9 in the bottom. I want it to have 18. If you want to change the way something looks, you take that something and you multiply it by good old 1. And 2 times 9, that equals 18. Don't look anywhere but what's in these parentheses. If that's going to equal 1, well, whatever you have at the bottom, you put on top. Don't look elsewhere. 1 times 9, that's going to be the new numerator. 9 over 18. A half is 9 over 18. 9 over 18 equals a half. Of course it does. I took a half and I multiplied it by 1. On one hand, it still equals a half. On the other hand, it's 9 over 18. Okay, 2 over 9 is surely equal to itself times 1. Never be afraid to multiply by 1. 9 times 2 gives me the 18. If I have 2 on the bottom, I have to put 2 on the top. 2 over 2 equals 1. And 2 times 2 just happens to equal 4. So, adding a half and 2 over 9 is the same as adding these 2 numbers. And when I add them, the denominators are the same by design. And I add the tops. 9 plus 4, 13. The answer is 13 over 18. 3 over 6 plus 2 over 9 is 13 over 18. And you should always make sure you can't reduce. Like always, let's try another one. You have 6 over 2, excuse me. If you have 6 over 2, and say you want to add 10 over 2, or 10 over 5 was maybe, that would be more fun. 10 over 5. Like I've been suggesting, before you bother to get common denominators and this and that, reduce. This is just 3. 6 over 2 is 3. But 2 times 3 is 6. Oh, that's 2. You have $10 and you share it between 5 people. Each person gets $2. 5 times 2 is 10. Now this is 5 and the problem's over. You don't always have to get common denominators. Well, in a way you do if they were 1. You should reduce first. It may make the problem a lot easier, like 3 plus 2. I never bothered to get common denominators. Look at how much harder this problem is going to be if we did get common denominators. The LCM of 2 and 5. Well, I know what numbers, what's on the 5 table. It's every number that ends in a 5 and is 0. I know what numbers on the 2 times table, every even number. Well, here are the first few multiples of 5. I'll stop right there. That's an even number. So it's 10. So you want to take 6 over 2, and you want to write it with the 10 on the bottom. So it equals 6 over 2 times 1. What goes in here will be 1. And I want a 10 on the bottom. Well, 2 times 5 equals 10, so I have to put a 5 on the top, because 5 over 5 is 1. 6 times 5 equals 30. So 30 over 10. 6 over 2, 30 over 10. Now 10 over 5, well, of course it equals itself times 1. I want a 10 on the bottom. Well, 5 times 2 is 10. So I put 2 over 2. 10 times 2 is 20. So instead of adding 6 over 2 and 10 over 5, I add these two numbers. They're equal to the original numbers, and the denominator is the same. By design, they're both 10. 30 plus 20 is 50. And 50 divided by 10 is 5. But I had that answer with much, much less work. I did the divisions first. 6 divided by 2 is 3. 10 divided by 5 is 2. 3 plus 2 is 5. Okay, is that always going to happen? Of course not. Not every fraction becomes a whole number. Not every fraction is a whole number. You have 3 over 15, and you want to add, say, 21 over 10. Okay, say 3 over 15. The first thing I would do is say, you know what, 3 and 15, 3 goes into each of those numbers. I really want to add these two numbers. And I want to find the LCD of the denominators. The LCD of 5 and 10. No, that's 10. 5 table, 5, 10. I'll stop right there, because I know 10 is on the 10 table. Even if you wrote some more numbers, 10 is the first common multiple. It's the least common multiple. Okay, so instead of adding 1/5 and 21 over 10, I want to add numbers, the same two numbers, but they need to have 10 on the bottom. Equivalent numbers. Well, 1 over 5 times 2 over 2. Why 2 over 2 and not 9 over 9? Because 5 times 2 is really 10. And 1 times 2 happens to be 2. I didn't really care what the top became. I care that the bottom is 10. Now, in the second one, you can just say, oh, the answer is 21 over 10. Or you can play the same game. What do you multiply 10 by to get 10? The answer is 1. 1 over 1. 21 times 1 is 21. So, instead of adding 1/5 and 21 over 10, I'm going to add 2 over 10 and 21 over 10. They're equal to the original numbers, and the bottoms are the same. 2 plus 21, 23. And there is the answer, 23 over 10. You have 8 over 3. You want to take away 1/6. Well, first you want to find the LCD or the LCM of the denominators. 3 and 6. Only 6. On the 6 table you have 6. On the 3 table, 3, 6, 9, you also have 6. And 6 is the first common multiple. I like to call it the first. It's also the least. I want to write 8 over 3 with the 6 on the bottom, and I want to write 1 over 6 with the 6 on the bottom. Well, 1 over 6 doesn't equal 2 over 6. 1 over 6 is not equal 11 over 6. 1 over 6 equals 1 over 6. If you want, you can say, well, I need to multiply 6 by 1 to get 6. So 1 over 1 will be the way I write my 1. And of course, 1 times 1 is still 1. Okay, 8/3 is equal to 8/3 times 1. Well, 3 times what gives me 6? 2. I must put 2 on the top. Because then, and only then, will that fraction be 1. 8 times 2 is 16. And please, you have to see how you're combining these numbers. In subtraction, we're subtracting these two numbers. If the denominators are the same, keep them, and then subtract the top. 16 minus 1 is 15. 3 goes into both of these numbers, 5 times and 2 times. And there is your answer. This is 5 divided by 2. Write another subtraction column. Subtraction is exactly the same as addition, except you don't add the numerators once you get the same denominator, but rather you subtract them. You have 7 over 6, and you want to take away 1 over 8. Well, you need to find the least common multiple of the denominators. In this case, it's going to be 24. 6, 12, 18, 24. Look at how, okay, you don't know it's 24 maybe. If you know your times table, you can make up this table fairly easily with no error. And then you say, oh, 24 is the first number on the list. So, I want to write 7 over 6 with the 24 in the bottom. I want to write 1 over 8 with the 24 in the bottom. Now, you don't have to do it exactly the way I'm doing. I'm just showing you the steps. I mean, you can take 7 over 6 and say, I'm going to multiply the top and the bottom by 4, and I get 28 over 24, and I'm going to take 1 over 8, I'm going to multiply the top and bottom by 3, and then I get 3 over 24, and I've been asked to subtract. The denominators are the same. 28 minus 3 is 25, and there's the answer. But on the left where I'm writing, I'm just showing you the logic. I'm going to multiply by 1 as 4 over 4. Why? 4 over 4? 6 times 4 is 24. That's the only reason. And 7 times 8 happens to be 28. They didn't care what the numerator equals, to be honest. 1 over 8 is equal to itself times 1. And since 8 times 3 gives me 24, I'm going to multiply by 3 over 3, which is 1. 1 over 8 is equal to 1 over 8 times 1. Of course, that's true. And let's multiply the top. 1 times 3 is 3. So we're doing 28 over 24 minus 3 over 24. Why are we doing that? Well, it does equal what's to the left, our original problem, and the denominators are now the same. 28 minus 3 is 25 over 24. That's your final answer. This completes the section on adding and subtracting fractions with different or unlike denominators. Get them to be the same.